Hi roboticist, and welcome back in this new video. And today we are going to hand over from the last video where, if you remember, we have generated a Moveit configuration package using the Setup Assistant tool. So that was a guided procedure, and what we're gonna do today is to practice with the Rviz using a Moveit configuration package. So as I already told you, Moveit provides an Rviz plugin that allows developers to set the planning problem. And if you want to access to that, you just need to open a new terminal and then type Rviz launch and then the name of the package that we have set up in the configuration package using the setup assistance, and that is gonna be cobots underscore Moveit tap configuration, and then we're gonna launch it the demo.launch. So, as you will see from this Rviz plugin, the desired pose of the manipulator can be set and a motion trajectory can be generated to test the Moveit planning capabilities. And here you can see our robot with our camera, 3D camera. And then this Rviz plugin looks like this. At the center here you have your robots, like an Rviz configuration, with the exception that here you have this plugin with motion planning powered by Moveit. And here you have the display section. And the most important thing, in the bottom left corner you can find the motion planning plugin, where you can see that there are a lot of tabs, and we are gonna look into it in a moment. So before to jump into it, make sure to subscribe to the channel, and if you want to support this channel for more content like this, where we're gonna talk about robotic and especially in the software domain and how to interact with the hardware, you can make a donation in PayPal with the link that I'm going to put in the description down below. And of course, put a thumbs up, and you are always welcome to reach me out in the comments if you want me to talk other topic like this. So that's enough for this introduction, and now let's learn how to use the Rviz Motion Planning plugin. Okay, so you can see here that at the TCP there are some arrows and round. So here the planning tab is very important, where you can see here in this section the query, meaning that you can select which type of planning group you want to move. This is depending on what you have configured in the setup assistant tool. In fact, we have created the arm that goes from the base link to the zero state to the home. So here you can see that the the start state is the current one, which is the zero. Okay, it's in red, and then the goal state is gonna appear here in green. And here in the command you can see that you find the plan, and execute. So if you press plan, you can see this by this animation the pathway that your robot will do to go from the start position to the zero position. And then if we want to execute it, let's click execute, and then you will see that the shallow, let's say, is continuing to publish in here, and here the red one is slowly reaching the goal position. So don't worry for the speed about that, because by default the execution is done on fake controllers, and we can change these controllers into trajectory controller for executing the planned trajectory in gazebo or a real robot. But this topic is something that we will cover afterwards. And then you can see here that the fake controllers allows the robot to reach the goal position. Okay, and don't make confusion in this animation. By the way, you can get rid of this just by untap here. And then you can see that the red robot is overlapping the green one, meaning that the robot has reached the current position. And then if we want to come back from the home position to the 0, 1, we just need to go here, and the start state will be home, and then go from 0. Then you can see that the goal state will be the 0, 1, and then the home is the red one. And here there's the option for the planning, and here there's the planning time, 5 seconds, meaning that your algorithm is set up for taking maximum 5 seconds to elaborate the path planning. And then you have the planning attempt, 10, meaning that if the inverse kinematic algorithm takes more than 10 attempts to reach the goal position, we can assume that there is no solution for the inverse kinematics problem. And then we have the velocity scaling. So as default is 0.1. And for example, if we make it 6 and just make a plan and execute, you can see now that the robot is reaching the goal position much faster than before. Another thing that we can discuss is this tab, the context. So I will not suggest you to change it, but this is the planning libraries and the algorithm set up for path planning and motion planning that we have set up in our setup assistant tool provided by Moveit. Okay, so now what we can do here is to play with the TCP, and for example, And so now what we can do here, let's go we spawn this robot on a gazebo, I don't think that you will find the solution, because this part will hit the floor. And so what we can do, for example, is to just left the object, then it turn it red. So meaning that another important feature of Moveit is that it tells you, with changing the color, if your object or your robot is going to hit, or better collide, an external object that you're gonna put. This is very important when you make some path planning to avoid some undesired position. Okay, so let's switch again to the arm. So now I would like to go more into detail in the display option. Okay, here there's the scene robots, and if there was something that didn't go well in the setup assistant, you will not be able to see any robot model. So this is really important. So if you launch the demo.launch file and you don't see the robots on here, just check here if you can see this displayed. So this is very important, the plan and path, where you can see the trajectory topic that is belonging to the move group namespace that we have seen, we have just talked in the last video. And this is the trajectory topic in which Rviz gets the visualization trajectory. And if, as I already told you, if we wanted to animate the motion planning and display the motion trials, we should enable this option. So, for example, by making this, we already see here. But sometimes make some